today's lesson, we are learning about composition of transformations. A composition of transformations is more than one transformation. Now, generally, when we're doing these in class, they will be in order given to you in which to do these. Right? Such as they will say, step 1, reflect over the x-axis, in which case we'll do that math, right? Flipping over the x-axis means our y values will flip their signs, right? And all these things build on each other from the first 4 lessons, okay? So our first example will be glide reflection, right? A glide reflection is a very specific version of this, and we'll do probably one of these. And what it is it's at first is a translation, right? And the second is a reflection over a line that is parallel to our translation. And again, parallel to step 1's translation. So for example, is if we moved maybe 6 up, then we're going to reflect over a line that is up and down, which would be like an x equals line, flipping us to a new value to the side. So we generally only do this on homework. I don't know that this will make the cut into the test area. But starting off here, we've got the vertices of triangle PQR are 2, 6, 4, 2, and negative 3, 3. So we graph those points quick, right? And this says the translation is going to be 4 to the right. Okay, so if I've got my points right here, just check it one more time. You have 2, 6, 4, 2, and negative 3, 3 if these points are correct. Right here's my shape, right, PQR, and then we're going to move 4 to the right. So switching colors here, moving 4 to the right, and you can mathematically calculate this as well, where you're basically just adding 4 to those x values. So we'll have 6, 6, 10, 6, and 1, 3. Oh, sorry, not 10, 6, 10, 2. Y values aren't changing, right? The y stayed the same. So just taking these points and moving 4 to the right. There's my new R, 1, 2, 3, 4 to the right, new P. And lastly, same thing for Q. So these are now technically R prime, P prime, Q prime. Sorry, P prime, Q prime, R prime. Okay, so there's my new shape. And now it says next we're reflecting across the x-axis, which again, reminder that's this line here. So now we're flipping what? Are we flipping the original or the P prime? We're flipping the prime, so now the red shape is what's moving here. And so now again, you're counting how far is Q away from the line, 2 away, so go 2 past. How far is P prime away from the line? 1, 2, 3, 4, 5, 6, and we're going 6 past. And lastly, R prime's 3 away, so we're going 3 past. And then our end result, we've moved twice now, so now instead of 1 prime, it is now double prime, where we do 2 marks. And so our diagram will look something like that. And I got a little bit of human error in there with this last line being a little off, and same thing here. But generally you get the same idea that our end result should be congruent if all our movements are isometries, which in this case, translation and reflection are. All the movements we've learned so far are isometries. The only one that isn't, we'll learn later. Next, the endpoints of MN are negative 2, 1, and 3, 4. Graph the image after the composition. So notice it's telling us, step 1, reflect across y equals x. Now, some of these might be ones that we calculated more than graphed, right? We would still graph them, but a lot of these, like this first step, we used a pattern of if our point's A, B, y equals x is going to flip them around. We're going to be B, A. It's going to flip our x and y values. So if M is minus 2, 1, my new point is going to be 1 minus 2 is M prime. And same thing with 3, 4 here. It's going to be 4, 3 is N prime. So again, graph our original. It's just a segment, negative 2, 1, 4, 3. this segment here, right? And now, graphing our new points, I'll switch colors here. We're now going to be at 1, minus 2, and 4, 3. Oh, I made a mistake there. I graphed 4, 3 already. It's supposed to be 3, 4. Undo. So there's our point. And the second point is going to be 4, 3. So that's after we moved. So there's my prime. Here's my original. So we got those labeled, and now, right, next we're rotating 180 degrees about the origin. This was another one where we didn't graph as much, but we did the pattern. So we're going to bring these 2 points down, and we're going to do the pattern. And again, this requires remembering a lot of what we did before. 180 degrees is like going from AB to minus A minus B, right? It's the same thing as if we multiply both numbers by -1. So we're just flipping our sign. So 1, -2 is going to flip to -1, 2. And 4, 3 is going to flip to -4, -3. And again, it's rotate, sorry, sounds like a flip, but it's a rotate. So switch it to one more color here. So our third color is going to be -1, 2, back over on that side of the line, and then -4, 3. -3, pardon me. And so our end result is here, we got M double prime, N double prime. There's a little bit of overlap there. As always, if I'm going a little quick on the graphing, feel free to pause the video so you can catch up. Next, triangle PQR's endpoints are -3, 5, -1, 1, and -5, 3. Graph the image after the composition. This time we're reflecting over the y-axis, and then we're translating +3 - 6, which again, some of these should be, hey, y equals the same, x flips its sign, right? So -1 times whatever we're at, right? And then with the +3 - 6 is 3 right, 6 down, right? Now order matters. We're not following PEMDAS necessarily. We're just doing reflection first, then we're translating. So in this case, reflecting over the y-axis again is a movement of basically -1 times the x values. So doing the math quick here, we'd end up with these points as our prime values. And again, if you're a calculating person where you like to do the math first, you can do this. If you like to graph, you could graph it, right? So we're putting the points out there. Here's P, Q, -1, 1, R, -2, 4, 5, 3. So we got a triangle here in quadrant 2. And now reflecting over the y-axis is this line here. And so we're now on the other side of that line, right? We're 1 away, right? This is the line we're flipping over. So for 1 away, we should be over here, 3 over, 3 here. And same thing, 5 over, 2, 4, 5. And so there's my prime. Oh, my R doesn't look very pretty over there, sorry. And now we're going 3 right and 6 down. So taking that last point, I can calculate that if I want to, or we commonly just graph these. So we'll kind of switch to a different color red here. And we're going 3 right and 6 down. Right? I think we should be -5, so just double checking the math here. And then you do that with each key point. So P prime, double prime is going to be there. But if I'm Q double prime one more time with R, I was 1 off on my P prime, right? I went 5, we need to go 6. So a little note, how did I catch that? I was looking at it, it didn't look right. Because if I went back to here, this distance didn't match this distance. So again, it's pretty important to catch, how can I catch errors? But you want to make sure my shape's going to be the same size. So even though this over here is 2 diagonals away, this one's 2 diagonals, so they're the same. That one was not, it was more, right? So that's part of how you can catch and just kind of look, does it look like the exact same shape? Because again, these are all isometries, we're looking for congruent. So that's how I knew this was a mistake, okay? Always good to be able to catch some mistakes. One more of these before we move to the last two types of kind of glide reflection named ones. So we've got ABC's endpoints are 3, 2, graph it quick, 6, 3, and 7, 1. 3, 2, 6, 3, 7, 1. We're going to move minus 12 plus 1. So again, this is, I could calculate here and do minus 12 from that row plus 1 here. If you're a type of person that likes to calculate, that's fine. Or you can just count. Now again, if you're like me, I'm not great at counting. So normally I would calculate as a backup. So I'm going 12 left, 1 up. So I got, there's my point A prime. All right, so B, we got 6, 12 left, 1 up. And then the same thing with C. Now notice, you can also use the fact that I know B is 1 to the right, C 2 down, sorry. C is 1 to the right, 2 down from B. That should still be that same distance when we move. So that's a way to help shorten how much counting you have to do there. And then lastly, 90 degrees rotation. So that's why it's useful to have these points, because 90 degrees is AB to negative BA. So now, right, the X values are switching position and the Y flips its sign. So now we're all in quadrant 4, because these are flipping 90 degrees here to down, right? So negative 3, negative 9, negative 4, 6, negative 2, 5. They color code very well there, so I can swap it quick. But there we go, now it's green. So that should be congruent in size to the original, right? So we're 2 over, we're kind of 1, 2, 3 over, 1 down, and then 1 over, 4 over, 1 down, 4 over from A to C. And then we want to label, right? So this is going to be A double prime, right? This was B double prime and C double prime. Very important to label your points. So that is, again, the kind of the goal of this lesson, to work on those double, right? We're practicing translating, rotating, reflecting, and a combination of both. Last two slides here are, we have parallel line reflection theorem. Is basically if we reflect over a line and then reflect over a line parallel to it, it's the same idea as if we just translated 2D, is basically, right? So now we're going to be distance 2D for the total, because this is also going to be another D, because these are congruent and these are congruent. And so because of that, we kind of have a parallelogram if we draw all our lines, right? If we draw this top line, it becomes a parallelogram. But that's basically what happens there, right? And so using that information, the distance from PP double prime is 3.2 meters. All right, so we're saying this is 3.2. What's the distance between K and M, right? This equals 2 times the distance, or 2x, and we just want 1x here. And so you just divide by 2. So 3.2 divided by 2 will give us 1.6 meters. The last one is a double reflection. If we have 2 lines that are not parallel and there's an angle between them, if we reflect first over this line and then over the next line, this is the equivalent of a rotation, really. But what we want to know is the angle between the 2 lines is going to be twice that of A prime. So reading it one more time, A is reflected across a line, 2 intersecting lines. The angle between these, right, is x, but the angle from A to A double prime is 2x. So going down here, just to explain it a little bit better, we've got an example where we went from blue to red, and then we're going from red to green to reflection. They're asking what is one translation that will work to go from blue to green. And again, we got 80 degrees here, so you got to do 2 times 80, gives us 160 degrees And from blue to green would be a 160-degree rotation. So we got a 160-degree rotation. And that wraps up today's lesson. Make sure you send me an email if you got any questions on this or the homework. Thanks.